All right, so here's the word problem we had given to us. What we're going to do is we're going to examine the pieces going by our protocols. The first thing we're going to do is we're going to identify the question. The question is typically located where in a word problem? The last sentence. So there it is right there. Second thing we're going to do is we're going to trim the fat from it. And in trimming the fat from it, we are going to identify the mathy words in our word problem, so to speak, units, things that can be measured, and all that. So the thing that I see is price. So I know that my value should be in a dollar sign or money value. Therefore, I hope to God it's not negative, because that means I lost money in the situation. Okay? And then here's another price. And so my units of measure are going to be senior citizens tickets and child's tickets. Therefore, those things identified in my word problem tell me what I need to look for in the other passage. And the other part of my passage is just identify the numbers. Still haven't read it, but I'm going to identify the numbers. And as I look, there's a 3, there's a 5, there's a 70, there's a 12, there's a 12, and is there any other? Oh, 216. Okay. Now, as I write those numbers down, I can use my units of measure from my word problem to tell me if they're what they're going to be in. So I got a 3, a 5, a 70, a 216, a 12, and a 12. So what units go with the 3?
First thing, you don't want an equation right now, right?
We're building the equation.
What I put is 3 and 5 and 70, I think.
Okay, so what is this 3 representing? Huh? Senior citizens tickets. And so I'm going to put those as S for senior citizens. And then the 5 is going to be the what? C for the child's tickets. And 70 is going to be? Okay. And so this one's also going to be dollars. The 12 is going to be my senior citizens, and the 12 is going to be my children. So one other thing that we could take back from the passage, even though we haven't read it, but right out beside each of the 70 and the 216s, it says total. Okay? Now, could we assume that that's a total?
Yeah.
We hope we don't assume anything, but they're a large value, right? 70 and 216 is a large value. And so in there, I can assume there a total amount of money made that night. And so therefore, I know that this is one equation, and I know that this is one equation. So this equation is created as 3S plus 5C equals $70. This equation is going to be 12S plus 12C equal to $216. Creating the equation should be the most difficult part of this. I hope it's something that turns into the easier part for us. I hope when we move forward that this is a skill that we take with us.
That actually was not the hard part.
Okay? So now then, now that we have the equation set up, we got to decide how to solve this system. It's a system because, one, I got 2 unknowns, and therefore, since I have 2 unknowns, I have to have 2 equations to do so. Now, this one right here, it lends itself to elimination a whole lot easier. Why? It's the standard form. Now, the other criteria says I need to look for a coefficient of 1, which I don't have, and I need to look for like terms and like variables, or like coefficients and like variables. I don't have that either. Okay? And so you're going, what do I do next? I can multiply the top one by a number that's going to give me a common one down here, correct? But it doesn't need to be 4, it needs to be what? Right, because I got to create an opposite. Now, I'll do it the other 2 ways. I'll do it with graphing, and I'll do it with substitution. Substitution is the ugliest here. I prefer not to have to do that. So I'll do it with elimination and graphing. Did anybody do substitution? So.
Just put it in brackets, whatever, and then just.
Okay, so therefore I'm going to change my equation. And so this is going to be negative 12S minus 20C equal to negative 280. Because you have the biggest problem people do is they don't multiply the number to the solution as well. This one did not change because I didn't multiply it by anything. And therefore, my 12s are going to go away, and this is going to become negative 8c equal to, say what? Negative 64. All right, divide by my negative 8, and I get 8. Right, now I can substitute it in to find the other one. So I'm going to use this equation just because it's smaller numbers. Okay, I'm going to subtract it. Alright, and so S is 10. So therefore I know that the price of the children's tickets is, or the price of a senior citizen's ticket is 12, or 10, and the price of a children's ticket is 8. Okay? Now, if I wanted to use graphing, I'm just going to give you the equations on how they would change. This equation right here, I'd have to decide and just go ahead and say that this is going to be my X and that's going to be my Y. This is going to be my X, that's going to be my Y. You can't mix those up. Okay? And so this equation would turn into Y equals, looks like negative 3 over 5 X plus, is it 14? 70 divided by 5, 14? Is that right? So that would be that equation. This other one would be Y equals negative X plus 216 divided by 12 is 18. So those would be my two equations that I would graph. So coming back to my graph, be Y equals negative parentheses 3 divided by 5 close parentheses X plus 14 and negative X plus 18. Graph. Will these graphs show up?
No.
Why would they not?
Zoom out.
Got to zoom out. I can almost see the point of intersection right there, but if I look at my y-intercepts of 14 and 18, then I'm probably not going to see the graphs very well. We'll zoom out. And there I see the point of intersection, so now I can calculate it. Choose the first one. Second one's got to go past the point of intersection. And I get 10 and 8. Now all you have to do is know that you are signifying what variable is what. Okay?